All right, good morning, e-learners. Share the screen. Where is my out of geometry? Where are you? That's not geometry. That is geometry. I am sure. You're going to like this one. This is a fun class. Well, I'm just saying it. I think it's fun.
I have a question.
What?
How much paper do you go through in a year?
I'm not like, I mean, like in a history teacher, they give you the big packets. I only give you one sheet of paper a day. So let's see, we have 10 months out of the year, probably a sixth to a seventh of those are test days, but then again, I give you paper on those days too. So let's just call it straight up, I give you a piece of paper every single day. There's what, 52 weeks out of the year. There's roughly 4 weeks per month. So 2 months we're not here. We'll take out, so that's 8. And then we have 2 weeks for Christmas, so that's 10. Then we have spring break and Thanksgiving break. That's another, so that's 12. So 12 weeks I don't. So 52 minus 12 is 40. But there's only 5 days, so 200 sheets of paper. How about that?
Really?
Yep. Okay. All right. So now that's enough off-topic stuff. We are going to have a quiz on Thursday. The stuff that we do today is primarily what will be on the quiz. We do an algebra review because I will show you the algebra part that we're going to use for this year. It's not that complicated. And then we will have this. So the only thing that will be on the quiz are 1, 2, and 1, 3. Like, what about 1, 1? Nothing on 1, 1 will be on the quiz, but it'll be 1, 2, and 1, 3. Today, lots of vocabulary words. I have lots of people that do poorly on this quiz every year, and it's simply because you don't pay attention to today's lesson and listen and have this, on a sheet of paper if you need to for the quiz. Remember, on any quiz or test, I allow you to write whatever you want on a sheet of paper, and it's open notes, right? So most people don't even make a resource card for my class with John because it's open notes. So take great notes. It's not open book, but it is open notes. All right, here's your homework. Write it down. And I will just say, you're not 7th graders anymore. You're a sophomore in high school. So the amount of homework goes up. Geometry is a hard one to judge. I mean, this is 26 problems. I give no more than an hour's worth of homework a night. But I don't literally say I want to give them an hour. I'm just saying I try to take maybe not the slowest kid in the class, but one of the slower students in the class. I try to use that as a guide and not make it more than an hour. There's plenty of you that will do this in 10 minutes, maybe 15 minutes. Others of you may take the full hour to get that done. Now remember, you have student advisement. I also allow you to get started in class if you would like to. If you want to do your homework in class, you have to pay attention. You can't say, I was doing my homework, I really wasn't paying attention. So some students really like, because their brain works fast, they like to have their book open to the homework page, and while I'm teaching, like, whoop, there's how you do that one, done. There's how you do this one, done. Other kids, that's way too much to do at once. I will leave it up to you. If you have an F in my class and you're trying to do homework, I'll probably stop you. If you have a passing grade in my class and you can do your homework while I'm teaching and you're not a distraction and you're staying on with the class, by all means. The only thing that kept my sanity whenever I took a high school level math class is the fact that all my teachers allowed me to do my homework in class. So it wasn't that I was bored, it's just that the pace that the teacher was going was too slow for me. Okay, so I just gave you a whole bunch of scary, hey, this is going to be challenging this year. It is, and today might be challenging even though it seems like it's going to be simple. Do I need to explain to you guys how to do homework, like what it needs to look like, or your 10th graders like, I got this? Math homework should always have your name. It needs to have mine. I teach 2 geometry classes, so you need to put the period so I don't confuse you guys with the other ones. They do not have the same homework as you do. Notice it says geometry and honors. You were in geometry class. It's close, right? It's close, but it's not the same. So if you're ever late for class, there's an orthodontist appointment or something like that, you can come write down the homework. right? It's listed right here. So today is Monday the 17th. So it has your homework written right here. I put a week's worth of homework up in advance. Not because I want you to get started on it early, just because I don't want to print this out 5 different times. So I just print 1 week at a time. So this is your backup if you forgot to write your homework down, you don't have any friends, you can't call, that would be bad. Or you had an appointment, you weren't here. Put the date, please, and then the section that we're doing. We're doing 1.2 today. And then you write question number 1. You're going to do a lot of, these are going to be, some of these are going to be a full page per problem. Not today. I'm saying because you have to have a drawing. Proofs take up lots of space as well too. Just don't write 1, 2, 3, 4 all the way to, what did I give you, 24, 26? What?
26.
Don't write 1 all the way to 26 because you'd be erasing all your numbers. So do the problem, circle your answer, and be done with it. 1.2. Okay. Those of you that have me know that I put little squares in the upper corner on some slides. If you see a red square, it means you're about to take notes. If you see a blue square, that means we're going to do a problem together. And if it's a green square, that means you're going to do it by yourself. Okay? Here we go. Okay, so this is points, lines, and planes. There is not a single word there that you have not seen before. Absolutely 100%. There's no way you get to 10th grade without at least have seen these words in a math class at least once. Plenty of times you've dealt with points and lines. You may have to be reminded of what a plane is, but you should be familiar with these words. Okay, so everybody needs to now, somehow you flick that switch, you're like, okay, I know I got a lot of stuff going on in my life, but I'm really paying attention. Okay, here we go. Oh, by the way, I put up objectives. I don't really mess with them until after we've done that particular objective, because a lot of times these words will mean nothing to you, although these are kind of easy, right? But we will revisit those once we're done with an objective. Okay, it's going to come fast and furious at you today. Like lots of definition, be ready to write. They look so young back then. And he's still alive, right? But not anymore. Yeah, he died in, ironically enough, a car crash because he was driving too fast. And he wasn't even driving, he was a passenger. Okay, here we go. The first definition in geometry is what? And it was the same thing for Euclid. His first definition was all geometry is made up of what kind? What's the most basic shape? All of those are made up of points. All right. Now, here is the paradox or the irony. Points are not shapes. A point is a position in space. It's a location. It's not a thing. You don't put a point in your pocket, walk over there and say, hey, here's my point, right? You can do that with a line segment. Okay, literally, okay, it's in my pocket. I can walk over here and hand him the line segment. You can't do that with a point. A point is just a location. It's not a physical thing. It has no size. It has no shape. You can draw your points as any, if you want to draw little teddy bears for your points, go for it. It's going to take you forever to do your homework, right? We do a circle because it's easy, and most of the time we put a dot. That is a point, but the key here to remember is it's a location. All right, I got to stop using carrots all the time. All right, look at Seth's head. Right? Look at Seth's head. Right now, his head occupies a location in space. Here's my fist. I'm going to punch him in the face, right? Now, in order for my fist to punch him in the face, both my fist and his face have to occupy the same space at the same time. Okay? If that happens, then I will not punch him. Yeah, but that is what we mean when we say location, right? All right. I will use that example. I was setting up for later, a couple classes later. I use that. Okay. Okay, so point is just a location. We designate points by capital letters. Not lowercase, but by capital letters. The capital letter can be anywhere on the page. Typically, we put the letter next to the point. But remember, a point could be any shape, could be a teddy bear. Sometimes you're going to see later on, our diagrams are going to get crazy complicated. crazy complicated, crazy complicated. I'm trying to find an example. There is none. Sometimes they will have to label it with the A right here and an arrow pointing to it. If you see an arrow pointing to it, that arrow isn't part of the shape. It's just saying, hey, there's point A. All right, is that new for anyone? Should not be. All right. Oh, by the way, I forgot I have new students. So box 1 has 1, 2, 3, 4 boxes. The top and second perfect. There's a spot for the definition, and that smaller box next to it was to draw the shape. Okay. The point's not that much going on there. Do I see students miss this? Never. Don't make this a challenge. I've never seen a student not understand what a point is, right? But everything beyond a point, I see mistakes all the time. Everybody gets the points. All the other shapes in geometry are made up of points or locations that are put together to form a shape. Like, wait a minute, you said it has no shape. Remember, it's a location. You string a bunch of locations together, you play connect the dots, you make shapes. So what's the next shape I'm going to talk about? All right, here is my weak attempt at an explanation. All right, this is a science thing, it's not a math thing. The top of this, right, is touching a point. There's a point floating in space. It's right here. So this is touching that point right here, right? So I have one point, and there's a second point. I have 2 points right here. This is touching a point in space. Imagine these weren't here. Those points are just floating. But I need that. All right. This little segment, right? Segment combines. When you play connect the dot between 2 points, you make a line segment. Not new. The question is, here's a specific line segment. I'm moving the segment around in space. How many points, and here comes your first big challenge, define this. This is a unique line segment, unique. It's different from, say, this one, right? They're completely different, right? They may be the same length, but they're completely different in space. So the question is, if I want to define this, how many points do I need to draw? 2, right? Because here's the difference. 1 point, is this line segment touching that 1 point? Is it touching that line segment? Is it touching this line segment? Is it touching this line segment? So 1 point defines how many segments? Well, here's one. Here's one. Here's a different one. Here's a different one. So 1 point defines how many line segments? Or I should say this, how many segments can you draw through 1 point?
It's a circle, so wouldn't it?
How many line segments can you draw through 1 point? Well, here's one. Can I draw another one that's different from that one? Can I draw another one? How many can I draw?
360.
Not 360. I can draw an infinite. Like I can keep drawing and never stop. That changes when you have, now I'm touching 2 points. How many line segments will touch those 2 points? Just one. Just one. So we say that a line segment is defined by how many points? By 2 points. Right? There's your first quiz question. A line segment is defined by 2 points. So box 1B. If you have, I'm sorry, I was jumping ahead. 1B is if we took all the points that exist, right? An infinite number of them, we put them together, you make space. Space meaning like space, 3-dimensional space, including outer space, right? All that put together, every single point that's possible is made up of space, or that's what space is made up of. I'll say that more precisely. It's just a collection of all points. We okay? You can't draw a picture of space, right?
Like it's on the planet.
Typically what they'll do is they'll draw a rectangular prism, a box, right? And they'll say space, but it's a box. It's only some space. All right. All right, so I just gave you the demonstration of a segment, right? So let's write that down 1C. So a segment is made up of how many points? Well, it's defined by 2 points, but how many points make up a segment? An infinite, right? This is where geometry comes from. Segments are made up of an infinite number of points, but it is only defined by two of them, right? This one and this one, right, define the segment. There is no other segment. How do I combine A and B? Well, if I do that, I would have to make what? Curve? Curve is not a line segment. Okay? Looks like an unhappy face now. Okay, so write this down, 1C, line segment. Part of a line. It's not the line, but it's part of it. That connects 2 points. Two points define a line segment. 1 point defines an infinite number of line segments. Once again, how many segments can you go through point B? Infinite. You never stop. You just keep drawing forever. Yeah.
Wait, so if we have the rule of the two line segment cannot pass through the point in the same space, then it is technically defined in the same way that our infinite numbers the other paper, like how we took 1 plus 2 plus 3 plus 3 plus 4, whatever it is, infinitely.
Right.
But it has the definition in the fact that it has that rule.
Right, and this is why if you cut this in half, and cut in half, and cut in half, you actually can still get from point A to point B, right? This is called Zeno's paradox. It's also called the Archer's paradox, or Archimedes in the hair, something like that, or torus in the hair. You know, how do I get to the wall? Well, I got to walk halfway, and then halfway, and halfway. We know from just common sense that I can walk to the wall, or if I shoot an arrow, the arrow will in fact hurt. Why am I being upset with it? All right, that the arrow will reach you, and it's called Zeno's paradox. Okay, we go with line segments. All right, can you remember 2 years ago how did we define a line? I mean, how do we write the name of a line segment? Chris, you remember? Like, what's the name of this one? It's not a line, it's a line segment. What's your guess? That's right. So we will define, or we will name line segments not by their middle points, not by any 2 points, but by the 2 endpoints. Okay, so he said AB. Chandler, you got another name for it? Is that the only name for this one? Connor, you got another name for it? So AB is what we're going with? Jenna? Harris? Wes? It's got to be a letter that's on. There's your other name for it. Okay, write this down. We will name line segments by the 2 endpoints. It doesn't matter the order the letters go in. Excuse me, if you want to go left to right or right to left, whatever floats your boat. What else do you notice about this name? It's got a line segment over the top. Some math books will put a dot right here, and a dot right here. Our book does not. So we just put a line segment over the top. That is how you will name all line segments. Or we can go from right to left, we call BA. Are there any difference between AB and BA? It's the same thing. It's like saying your name is Seth, or it is, no. Give me another name.
Israel, Elijah.
All of those mean Seth, right? But they're different, right?
I mean,
they define the same person, but they're different. Okay. These don't mean anything else other than they're just names. Hey, you can say this is a first name, middle name, or first name, last, whatever. Everybody understand that analogy there? Okay. Is that new? Chris, that can't be new for you, right? You saw this about 2 years ago, pre-algebra. Okay. All right, since you brought it up, Chris, how many line segments? Unique. Unique means different. How many different line segments do you see up there? Or I'll give you an easier one. Give me a line segment that you see. Do you see a line segment up there? Which one do you see? Tell me a line segment. Give me one of them that you see. XY. So Chris sees this one right here. Okay? And he said that was XY. Sounds good to me. So we put an X, we put a Y, we put a line over the top. right? What do you see? XZ, is that the same or different? That is different. XZ is this big long honking one right here. So she sees XZ. Anybody else? A unique one, different than those two. YZ, that's kind of like the medium one right here. So YZ. Okay? But then we have what? The opposite way. Give me the opposite way you say every one of those. Yeah. Give me the opposite way to say that. Keep going. Okay. That should be something, and I think I have it nicely written here. I just don't think I did it in the order that you guys. Oh, no, I did exactly the same order you did it. What do you know? No, she gave me the long one first. Okay. So these horizontally are the same ones, yes? But vertically, they're all different. So it turns out there's 3 line segments up there. There's 6 different ways of saying those things, but there's only 3 line segments. Tonight for homework, they're going to ask you questions like that. They're going to give you something like this and say, name the line segments. Now, you don't have to say both ways. XY is the same as YX. But if there's 3 different ones, they're trying to have you name the 3 different ones. No, that would be all 6, right? They're going to say, how many unique line segments? That means I got a small one, I got a medium one, and I got a big one. But you get to choose which way you name it. So if you say XY, Seth says YX, I'm going to say, yes, you're both right, to name the small one. Okay? Your brain's still turned on? Okay? All right, now we're going to get really stupid. Sometimes we get stupid in math. Okay. Amaya, what's the name of that line segment? Perfect. That's its name. With this over the top, right? Okay. How long is AB? What would you need? Okay. Here's my ruler. I'm going to measure this, and I should have looked at my slide so I can make up a number. It's that long. Yes? You agree I could do that? I can measure it? So how do we write how long it is? This is where we get stupid in that. It is, but we will leave. That's the name of it. It's AB or BA. When we say it's measurement, we get stupid. For some reason, some mathematician, it wasn't me, said that when you write its distance, how long it is, we leave this bar off the top. It is confusing at first. You will not be confused a month from now. But when you open up the book and you see this, Chandler, what does it ask me to look at? If you see the bar over the top, what does it ask me to look at? Its name. When you don't see a bar, guess what it's asking you to find? The length. Okay, there's your first. I got to wrap my head around that right there. No bar, they're just saying, give me the name of it. I'm sorry, with a bar, give me the name of it. Without a bar, tell me how long it is. Tell me its distance. You need to write that down, write that down. If you're like, I can remember that, you'll be okay.
Like in Latin, you have a macron, changes it completely the word's meaning. Whereas if you did have one,
yeah, and this to me makes no sense as a mathematician. You can put a bar over the top as long as you give me an equal sign or you tell me measure it, I'd be okay. But for some reason, and this is universal, and any math book does it like this. Okay, we all right to move on? This will cause confusion. And tomorrow when we grade homework, a few of you will say, oh, they wanted the distance. I thought they were asking the name of it. All right, so think about this. This is in box 1D. If I have a point, right, and I have another point, and this time when I play connect the dots, I don't stop.
No.
Line.
Guess what you made?
A line.
You made what's called a line. So a line is defined by how many points? Okay, a line has an infinite bunch, but what defines it? Like, what makes this line unique from that line? It goes through these 2 points. Notice here's another line that goes through point B, but it doesn't go through point A. The only way I get another line to go through point, I'll break this, is if I curve this, and that makes a curve. You can have an infinite number of curves that goes through 2 points, but only one line goes through 2 points. So a line segment is defined by how many points? That's what I'm saying. A line segment is defined by how many points? A line is defined by how many points? 2. But both a line segment and a line have how many points? An infinite amount of points. This is, like I said, this is the hard part of geometry. Wrapping your head around that concept right there. So it says an infinite series of points that extend in opposite directions. We name lines by how many points? 2. Guess which 2 points you need to use to name a line?
2.
Any 2 points. A line segment must be named by the 2 endpoints. A line doesn't have endpoints. So you can pick any 2 points. And here's where, again, we get confusion. Line segments must be named by their endpoints. But lines, any 2 points. Any 2 points. What's the symbology for a line? What's going to go above AB? It can't be a little bar, because that would make it a line segment, like an actual line. Thirdly, to further confuse you, and you will see this in the book, sometimes when the diagram gets really messy, right? And I think it does today as well too. When it gets really messy right here, when it gets really messy, they don't put points on the line. They'll have a lowercase italicized letter. And they love the letter, Micah, look at the book. They love the letter. They love the letters L. L for line, maybe, right? They love the letters L and M for some reason. Sometimes N. So if you see a lowercase, there's no dot here. That's just the name of the line. It's line N. Now, if you're going to use this, well, we can't say that. So we literally use the words N, or line N, or line AB. Any one of these 4 is the name of that line, and it's starting to get overwhelming to this point, right? So many names, so many different ways of doing this. I will tell you, it will get easy, just not today. You won't be thinking about this a month from now. That's crazy, that there's 4 different ways. I mean, it's really just 3, this way, or that way. There's that many ways of naming it. Can you measure a line, like how long a line is? No. So you will not have a measurement of a line. A line is not 3 inches. Line segment could be. A line has no measurement because it's infinite. It goes on forever, never stops. Okay? But a line segment, with a bar over the top, that's its name. Without a bar, or asking you how long it is. Okay? Where are we at? Or is our head above the water, right? Okay.
My fingers.
All right. Cadence, what is that? Are you sure? How do you know it's a line? It's a teacher thing when I do stuff like that. How do you know it's a line? I mean, don't overthink it. How do you know that's a line? Okay. Even better, how do you know that's a line? It is going through 2 points, sure. Why is that not a line segment? Don't overthink this. What do you got, Karis? Literally, it's got arrows. That's how you know it's a line. Now, somebody might argue that is a line segment. What argument is that? Somebody says, no, that's a line segment. Is that a line segment? Why do you mean? How would you justify that? There is a line segment there, right? What's the line segment up there? There is a line segment, right? So if you want to say, what do you see? Well, I see point R. That's what I see. But if you want to say, what is the whole thing? Like, everything up there is a line, but there's parts to make up a line. There's points. There's line segments. There's also rays. We'll talk about that next. But yeah. So tonight for homework, if they say, what do you see? They're asking the question, give me everything. I see 2 points. I see 1 line segment, and I see a line. Okay? All right. So yeah, it is GR or RG. All right. This is more like homework. So we'll start with Chandler. Give me anything you see up there. What line do you see up there?
AC.
Now listen to what I'm saying. Is line AC the same or different than line AB? Is line AC the same or different than line AB? What's the definition of a line? Goes on forever, never stops. Here's line AC. Goes on forever, never stops. Here's line AB. Goes on forever, never stops. So is there any difference between AB or AC? Line. Not a difference. Right? But there is a difference between segment AB and AC. Just a little bar over the top of it. All right, so line AC, and that was the one I picked as well, is no different than line AB. It's the same line. It's no different than BC. All of these are the same line. Lines are different. Okay? All right. This is a new vocabulary word, and the book doesn't have us write it down. So we'll see. If you need to write down, write it down. How about
Who's calling me?
Caleb? That's the word collinear. You want to take a stab at what you think it means? Collinear. Liam, you want to take a stab at it? Okay. Could mean two lines. Oh, right. Maybe it's two. Want to take a stab at it, Seth?
Linear. There are two lines, line segments, or other points. Linear research.
Okay. Danny, want to take a stab? All right, I'll give it to you. If you cohabitate with someone, what does that mean? You live together. So collinear means you live on the same line. Collinear, we're going to see this word, collinear, coplanar, cosegment. Collinear means you live on the same line. So points A, B, and C are collinear. Why? They're all on the same line. If they're on the same line. If they're on the same line. What's the opposite of collinear? What does non-collinear mean? Karis, what would non-collinear mean? That means you got a point that ain't on that line. D is non-collinear to line BC, AC, or AB. Tonight for homework, you're going to see that word, collinear and non-collinear. Just means you live on the same line, ray, segment, whatever. All right. Non-collinear. B is non-collinear. A and C are collinear points. They're on the same line. Okay, we're going to do one of these. They're going to give you a funky shape that looks like this, and they'll say, what do you see? So we'll start with Wes. What do you see? Give me something you see up there. See what? T is lowercase italicized. It only can refer to a line. So line T would be this one right here. Right? Madison, what do you see? Anything. What is that? There's three possible answers to that. C and D. C and D could be any one of the shapes that we've said so far. Give me one. Could be a line segment. It also could be the line, and it could be points C and D. Tonight for homework questions, find me one. Question number one through 10, all ask this stuff. Okay. We okay? Do you see anything else up there? Lots of things. What do you got? Rays. We haven't talked about rays. We'll get there. Okay, so that's what they're going to be asking you to do. So you can name the points, you can name the segments, you can name the lines. Yes? Is there any difference between line CD and line BD? Lines are, it doesn't matter, just 2 points on the line. Notice this is not a line. It starts here and goes one direction, and obviously it's right there. It's okay, I typically only have other examples in case we need them. And we're not going to do this one. So let's move on to planes. This is what my teacher did. She held up a whiteboard and she said, flat surface, like your desk. A flat surface, not the surface itself, but the idea of the flat surface that goes on forever. In that direction, in that direction, in this direction, and that. Not up and down. This flat surface, imagine this goes on forever, but not up and down, is a plane, right? That's your idea of a plane. All right, now, how many points define a plane? I mean, there's an infinite number of points on this plane, but how many points? Well, let's think about this. 1 point. Watch me. Here's a plane. Here's a plane. I'm touching the same point. Here's a different plane. I'm touching the same point. Here's a plane. How many planes touch 1 point? You okay with that? Right? This one is different than that one, different from this one. There's an infinite number of points that touch, infinite number of planes that touch 1 point. How about 2 points? 1, 2. How many planes touch? We know that one line touches those 2 points. But how about how many planes touch 2 points? Well, do you agree that that's one? I'm touching both those. But that I can turn it this way, I'm still touching those 2 points. There's another one, and another one, and another one, and another one, and another one. How many planes touch 2 points? A lot. How many different ways can I lay this onto 3 points? Show me another way. You got to touch all 3 points. You're not touching that point. You're not touching that point. You're not touching 2 points. How many ways are there to touch 3 points with 1 plane?
I did it.
Right. 1. There's only 1 plane. Oh, and practical, this is why stools have how many legs?
4.
You have 4, guess what? It wobbles, just like your desk wobbles. You have 3 points, it will never wobble. It can't. Why? This is the ground. It has to touch. Now, granted, it could be tilted, right? But it has to not. That's why 3-legged stools are always stable. Right. If it's broken, then it's going to be like that. Right? Anyway, 3 points define a plane. There's an infinite number of points here, but 3 points define a plane. So, summary. 2 points define a segment. 2 points define a line. 3 points define a plane. All right, write this down. Oh, one slight problem. How do you draw a plane? It never stops. We can't put arrows on it. So here's what they do. They draw this shape right here and say, that's a plane. But in your brain, you have to remember it goes forever in that direction, in that direction, in this direction, in that direction. In your book, you're going to see tonight for homework, green. That's a plane. It doesn't look like a plane. It doesn't go on forever. It stops. Looks like a parallelogram, which you don't know what it is yet. But they will draw planes as parallelograms. All right, write that down. Box 4, plane. It's a flat surface that extends in all directions. And you got to be careful. It's saying in all directions. It doesn't mean up and down. Of course, all directions would mean up and down. It's kind of a paradox. It means continue that surface and don't stop. So a plane is a flat surface that extends in all directions, just not up and down. I said, how many points define a plane? 3. 3 points define. 2 points defines an infinite number of planes. 1 point, an infinite, but 3 define just 1 plane. So guess how we're going to name a plane? By 3 points. Any 3 points on that plane will be the name of the plane. Generally, it's got, the way they draw it, it has 4 corners. Doesn't say you can't use 4 points, so sometimes they'll either use 3 or 4 points to find, and usually the corners. 3 points to find a plane. I just showed you that. Are we getting really close to being on full? Right? Okay, so here's 3 points on the plane. How do we know these points are on the plane? Yeah, so this is where it gets really lame. Well, remember, this goes on forever. It doesn't stop. Well, if it doesn't stop and this is a flat surface, then how do you show that points are on the plane or off the plane? I can do that pretty easy with this. Hey, I put a dot right here. That point is on the plane. There's another point up here. That makes perfectly sense right here. Not when you try to draw it. So here's what they do. If it's inside the blue, it's on the plane. If it's outside, it's off the plane. This is a requirement in order to make it look right in 2 dimensions. So if those are the name of the points, what's the name of this plane? Yeah, ABC, CBA, BAC, CAB, any order you want. Right. They have to be shown on the plane. So for instance, there's a dot right here, D, the D is not on the plane. Just trust me when I say there's a second way to name a plane. There's a second way to name a plane. This can get messy, right? We may want to draw things on plane. Are you guys with me? Right? You may want to draw things on the plane. So what they do is there will be a letter floating around, capital letter. It'll just be floating around. There's no dot here. I'm sorry, but this is what they do as well. This will be called plane B. Okay? Tonight for homework, you'll see, right? Plane M. Plane M. Yeah, plane R, S, and yes. Okay. We good? All right. Now comes the fun stuff. 3 dimensions. When you draw a line or a segment or a ray through a plane, well, it looks like this, right? Really easy, right? There's a hole. How do you draw this? How do you draw what I'm showing you right now? Can you see this part right now? Can you see it? Can you see where my fingers are right here?
Again.
No. So how do you draw that? Yes. We will use dotted lines. Watch. So how do you draw that? What's the name of this plane? Okay. Here's point A, and I'm going to draw a line through A. I literally just did the same thing. Now, she said a dotted line. Notice the whole line isn't dotted. So what does this dotted portion mean? Is that above it or below it? You see a dotted, that means it's either not seen or it's below. Does that make sense? This is the line. If I hold this, this will be like this, right? And it's going like this, right? So you guys can see, guys can see this portion, that portion. You can't see what's directly underneath. You guys really need to pay attention. Seriously. Okay? So they put the part that's behind as a dotted line. Make sense? Okay. Where's line K?
It is on plane M.
Well, how do you know it's on? There's no dots, and it's not outside the little parallelogram. This is confusing at first. Okay? If it's not inside this, now remember the plane goes on forever. It's a joke, right? The plane goes on forever, but you got to be able to draw it in 2 dimensions. So these are the things we have to do in order to make it look right. So if it's inside, it means it's on. If it's outside, it means it's not on the plane. So line K is not on the plane. Neither is line J. It's not on the plane. It goes through the plane. Okay, non-coplanar, what do you think that means?
Not on the plane. 2 points on
This point is on this plane. Where would be a point that's non-coplanar? Where would it live?
together.
Down here, up here. It's just not on this flat surface right here. That's what non-coplanar means. Not on the same plane. Not on the same plane. All right. I can either call this plane M or plane ABC, right? All 3 points are coplanar. Why? Because they're inside non-coplanar. Yes? One thing left. Here we go. Write this down. Our shapes can intersect each other. What does the intersection mean? That means when, we'll go back to fist and head. That is when two objects occupy, I'm not going to get you. When 2 objects occupy the same space at the same time, they intersect each other. They intersect each other. When 2 objects occupy the same space. Now, if you want to do 4 dimensions, we have to say it at the same time. This is how you don't get punched. Is when my fist occupies the space of your head at a different time. 5 minutes from now, you're not sitting there, and my fist goes there, then nice. Okay, let's wrap this up. When 2 line segments intersect, what do they make? When 2 line segments intersect, what do they make? What shape do they make? What shape the intersection? What shape does the intersection make? Oh, that's the 2 sides. What shape does the intersection make? Well, how many places do they intersect? So what do they make? A point. Good job. They didn't get it. You guys got it. All right, here comes the last thing we'll do. 2 planes. When they intersect, what do they make? Not talking about the complete shape, but the intersection. When they intersect, what do they make? How many places are they touching? Oh, way more than 1. They make a line. When 2 planes intersect, they make a line, right? They're touching a line, and that's where we're going to end today. So, when 2 line segments or lines intersect, they make a point. When 2 planes intersect, they make, oops, sorry. Get out of here, what, right now? Yes, we are right on time. All right, questions. All right, give homework a shot. Come ready to ask questions. Also, you got student advisement today. If you struggle with something and none of your partners can help you with it, I'll be in this classroom. Come get me. I'd rather give you assistance on this homework than to let you sit there and struggle. Sayonara. До свидания. Bis später. Tschüss. All right, e-learners, if you guys got questions tonight for homework, send me your email. I'll be more than happy to answer them.